continue our calculus 2 section 7.2. We did this method. This is still 7.2. We're gonna do the washer method. The difference between the DIST method and the washer method is that the washer method you have a hole. As you can see in the picture here, you have a circle, the bigger circle here, and the smaller circle here, which is a hole. And we want to find the volume of this without the hole. So we have to find the area of the bigger circle minus the smaller circle. Capital R of X is the outer radius. Small r of X is the inner radius. So the volume of this without the hole, we have to subtract the smaller radius square from the bigger radius square, and then calculate the volume of this. So let's look at an example. Find the volume of the solid formed by revolving the region bound by the graph y equal to x squared. Y equal to x squared. If you square both sides, you're gonna have y squared is equal to x. Another word, if you rewrite this, is x equal to y squared. This is a parabola. This is x is equal to a y squared plus by plus c. Our a here is equal to 1, which is greater than 0. This is the parabola open to the right. You can see the line, the green one here is the parabola open to the right. If I continue to the fourth quadrant, it's going to be parabola open to the right. Now let's look at the second one here. Y equal to x squared. This is also parabola. Y equal ax squared plus bx plus c. Excuse me. In this case, a is equal to 1, which is positive. So you're going to have a parabola open upward. You can see the blue graph here is parabola open upward. This is just the first quadrant. If you complete the second quadrant, it's going to be a parabola open upward. Now, we're going to rotate this around the x-axis. So you rotate this two graph around the x-axis. So basically you have the radius of the smaller one, r of x, and the radius of the capital X, capital R of x. And that is a hole here. This is the two-dimensional graph. Now let's take a look at the 3D, three-dimensional graph. Oh, by the way, I did solve when the graph is intercept. So if you set these two equations, which is square root of x equal x squared, you will see that the intersection, the intersect between the graph is at point 0, 0 and 1, 1. This is the point that the graph crossed, and this is also the point where the graph crossed. So let's look at the 3D of this picture. As you see earlier, I did graph this for you already. This is two-dimensional. Let me make it three-dimensional and rotate around x-axis. Well, this is the graph of three-dimensional. So they want you to find the volume. So as you remember, this is the parabola open to the right for the first and the fourth quadrant. And this is the parabola open upward. If it's rotate around x-axis, you will have this picture, as you can see right here, in different direction, right? Here we go. So we want to find the volume of this, which is this part right here. Sorry. All right, that's the idea. Just load it again so you see. All right. All right. All right, let's go back to our calculation. Here we go. This is our calculation. As you remember, the formula that I gave it to you when we first start, the volume is equal to pi and integral from A to B, the radius of the bigger circle square minus the radius of the small circle square dx. That's the formula. So basically you take out the whole. So let's continue our formula. So I have pi is a constant. So the integral with respect to the x, so you take an integral from 0 to 1. Alright. Now the bigger circle, the radius is from here to here. So the radius is from here to here, from the x-axis to the green graph. Alright. So it's going to be square root of x square minus the smaller circle, which is from x axis to the blue graph. So it changed, as you can see here. So we're going to subtract that, which is x squared. I forgot the square here. X squared, but we have to square it dx. So that's our formula. I plug it in. Now let's simplify this. Pi is pi, and integral from 0 to 1. I'm going to rewrite this as an exponential. So this is going to be square root of x is x to the 1/2 quantity square minus x to the 4th of this dx. Let's continue. So from here I would have pi and integral from 0 to 1. If you simplify this, 1/2 raised to the second power is just x minus x to the 4th dx. Then the rest of the simplify here, you just take an integral of x is going to be x squared over 2 minus x to the 5th over 5, and integral from 0 to 1. See if I can move this down a little bit. Yep. Alright, so it's not so messy. So I would have pi, your lower bound is 0, your upper bound is 1. So substitute 1 for x, you're gonna have 1/2 minus 1/5. That's the upper bound. The lower bound, if you substitute 0, you're gonna get 0. Alright, now I'm gonna simplify this. LCM is just 10. Then you're gonna have 5 minus 2. So the answer is 3/10 pi. So that is the volume that we are looking for by using the washer method.